Alright, this video we're going to look at doing some moves. So we'll create ourselves a project. This will be 64-bit. Go ahead and make our project and open it with code. Alright, so the main thing we want to do here is we just want to look at the different pieces that go in data, and we will be printing them. So, for example, we can define different sizes of word. So we can start at my variable called my byte. So I'll make this FF. And then we can do a word. So let's do, so these are in hex. We will talk about how hex works in another video. So we have a byte is 8 bits. In hex, that's represented as 2 digits. A word is 16 bits, and so that's 4 nibbles, which are hex digits. My D word. Oh, I used letter O, not zeros. Okay, so that is 8 hex digits is 32 bits. And then my quad word, let's do something like that. Now, inside of our main program, let's close this. We'll get our terminal up. So when we do it, so one thing I want to use is dump registers. So we can do a variety of different moves. So we can move from these data locations. So we can do, for example, move RSI. We can pick any of the ones that we want to do. So for example, if we do my byte, that will do all of the data that's there. So if we go ahead and call dump registers, and we do make, and oh, I needed to put the brackets around. So when you go and get data from a memory location, you want to get the data at that location. So this will fill in the location of where my byte is, and so we want to get the data at that location. So and then we can just do this. So this will clear our screen, make the project, and then go ahead and run it. I'll make my screen a little wider so we can see all of this. So we can see that if we move into RSI, the value at my byte, go down here and find RSI. So we can see that we grabbed not only that byte, but we grabbed all of the other bytes that we probably didn't want. So we grabbed the data that's in my word, and we grabbed some data that's in my D word, and then we actually grabbed some data in my quad word. So if you want, you need to make sure that you don't do that. So let's say we take my byte, and if we only want a byte, we can only grab a byte, but what do we want to fill it with? And so I'm going to use 0 extend. So that will fill all of the bits in the top with zeros. So now we can see RDI just got that single byte. So that's one way to grab it. You could also use a register that's only of that size. So here I'm going to move into RAX. I can say move 0, and then we can look at AL, or the lowest part of RAX, and that's FF. Or I could move into RAX 0xAA. Let's do that. So now we can see that when we did that, right, AL is the bottom 16 bits, sorry, bottom 8 bits of RAX. And so it left all of the bits that we put on the top and then moved them in there. But if we did something like move 0 extend RAX my byte, and then call dump registers, we should get 2, oh, I misspelled my underscore byte. And, oh, we have to say how big we want to do. So if we say we want a byte, we can grab a byte. And now it grabbed that byte, and then it 0 extended all the rest. Additionally, there's one called sign extend. So if we have the top bit is 1 value, is a 1. So when we write out our bits, if the very top one is a 1 and you do sign extend, it will extend that sign all the way out. So we could do an example of that. So we'll pick a byte that doesn't have that. So let's say 40. And then we can do, instead of 0 extend, we can do sign extend. Now the top bit in this should not 124 is not set. So 8, it would be the top bit. And that is not set in that value. So they all get set to zeros, but if it had a value like 80 or an uppercase letter or 9 or anything like that, then that bit is going to be proliferated all the way up to the top. This is how it has to do with signed numbers. We'll look at those a little later when we talk about 2's complement. So additionally, we can save values back. We can modify just 1 byte. So for example, if we have my keyword, move into, let's pick one, doesn't matter, RDX, my keyword, and then so RDX has, for example, DL or DX. So I could move into DX, a particular value. And then I could write that back. Move to my D word, RDX. And so RDX should have our value in there where we just, so this is going to be the equivalent of 00BB. So if we look at, so this is RDX, A, B, C, D. Oh, and then I need to dump registers. There we go. All right. RDX, we can see that these bottom bits get set to 00BB. If I don't put the zeros, it's the same thing. So I rerun it, same output as before. And optionally, you can write to a particular memory location. So if I want to do a move of, let's look at our variables. So I don't have any AAs. So let's move into the location at my keyword. And let's say I wanted to move 0x AA. So this is a D word, so I can move that into there. If I say it's a D word, right? So our sizes are byte, D word, and these D's stand for define. So define byte, define word, which is 2 bytes, define D word, which is 2 D words or 4 bytes, define quad word, which is 2 DDs, and so on. Oh, I gotta save my program. All right, so if we look at my keyword, it gets moved. We move the data here on this line, and then we move it into RDX. So, which actually gets overwritten because we picked a D word. So I guess there are zeros in there. Let's do this so we can see it in our result. So now we see the A's. If we had looked at this, so if I comment out these and look at and move the value into RDX, we can see that it was filled with A's in there. So you can, there's a couple different modifiers with standard move. We'll talk about conditional moves later, but with the standard move, you can do things like 0xtend and sign extend in order to fill the bytes, or if you give it a hard-coded value, and if that hard-coded value is slightly shorter, so if I just do 0xAA, right, the rest will be filled with zeros, which I didn't define. They're implicit because I said I wanted a D word to be written to that spot. Another one is that all of this memory that we define in data is contiguous, and so that's why initially, right, I'm allowed to read as much data as I want out of there, right? So if I go and just try and read data into a register from my byte, it's going to grab all of the contiguous data beyond my byte. So this is kind of a brief introduction to both your variables in your data section, how you move data into and out of them, and how you can specify how you want it to extend or what type of move you want it to do if they are of different sizes. So if this is of a smaller size and this is of a bigger size, we have to tell it how much data we want to move, and then we can tell it if it is from a smaller to a bigger, how we want to do the extend, 0xtend or sign extend. All right, thanks guys.